Welcome to The Explainer. Today, we're literally stepping inside one of Japan's most iconic sports drink factories to see exactly how POCARI SWEAT is made. We're going to explore the absolute massive scale and, honestly, the mind-bending precision of a modern manufacturing workflow. It's an incredibly sophisticated operation, and it perfectly combines the delicate chemistry of beverage production with some seriously cutting-edge, heavy-duty factory engineering. So, how are millions of bottles made every day? It's something most of us just never really think about. But behind every single bottle of your post-workout hydration lies this incredible, entirely hidden world of advanced robotics, complex water treatment, and massive logistical networks, all working together in absolute perfect harmony. It's like a highly detailed symphony of manufacturing, and we're going to break down the engineering and science behind it step by step. Okay, let's dive into this. Here's our roadmap for today. First, we'll go inside Japan's drink factory. Second, we're crafting the electrolyte formula. Third, shaping the plastic bottles. Fourth, we'll look at the automated bottling process. And finally, number 5, packaging for the world. All right, section 1. Inside Japan's drink factory, setting the scene. Walking right onto the factory floor, the very first thing that jumps out at you is just the endless expanse of gleaming stainless steel machinery. And actually, this isn't just an aesthetic choice. In beverage manufacturing, food-grade stainless steel is an absolute non-negotiable requirement. It's highly resistant to corrosion from acidic liquids or harsh cleaning chemicals, and most importantly, it absolutely doesn't harbor bacteria. Every single vat, pipe, and conveyor belt is engineered for ultimate durability and incredibly strict hygiene. That ensures all this heavy-duty automation can just run nonstop, around the clock, without ever compromising the safety of the product. And all that pristine machinery, well, it operates within a highly controlled, hyper-clean factory environment. I mean, when you're dealing with electrolytes and human consumption, the sanitary requirements are just off the charts. The air quality, the temperature, the humidity, it's all meticulously managed. Why? To prevent literally any airborne particles or microbial contamination from messing with the drink. It's a completely sterile, carefully pressurized setting that creates the absolute perfect baseline for safe, large-scale beverage creation. Moving on to section 2, crafting the electrolyte formula, the birth of the liquid. So this whole process starts with the absolute foundation, pure water purification. Before any flavor or mineral is even introduced, the raw water goes through intense filtration. They're often using reverse osmosis to strip out any existing impurities or unpredictable minerals. Once you've got this perfect, blank liquid canvas, we reach the critical phase, mineral and electrolyte mixing. Now, sports drinks require a very, very specific ionic balance of sodium, potassium, and magnesium to actually match human body fluids. This isn't just, stirring some powder into water. It relies on continuous ingredient quality testing, using highly sensitive sensors to make sure the concentration is exact down to the literal microgram. From there, this precisely calibrated mixture is scaled way up inside large, agitated stainless steel blending tanks, creating a beautifully uniform, perfectly balanced formula that's ready to drink. Next up is section 3, shaping the plastic bottles, the physical vessel. Now, while the electrolyte formula is being engineered over in those blending tanks, a parallel process is happening with the packaging. And it all begins with something called a PET bottle preform. Essentially, it's a tiny test tube-like plastic mold that serves as the starting point for a full-size bottle before it actually undergoes the blowing process. It is truly mind-blowing to think that those massive, durable sports drink bottles you grab off the shelf, they actually begin their life looking just like a thick, tiny plastic test tube. And there's a brilliant reason for this. Shipping these small preforms rather than empty, full-size bottles saves a massive, massive amount of logistical space and energy. The transformation from that tiny test tube to a full bottle relies on this absolutely fascinating piece of engineering, the bottle blowing machine. First, the preforms are rapidly heated up to make the plastic super pliable, but crucially not melted. Then they get dropped into a steel mold that's shaped exactly like the final bottle. A rod stretches the plastic straight down, while highly pressurized air is blasted inside, which forces the hot plastic to instantly balloon outward and snap perfectly against the walls of the mold. And guys, this all happens in just a fraction of a second. Immediately after taking shape, the brand new vessel undergoes rigorous bottle rinsing and sterilization with purified water, just to guarantee it is entirely pristine before it ever touches the drink. All right, section 4, the automated bottling process, the grand union. Okay, this is the exciting part.
This is where the perfectly balanced liquid and the freshly molded physical bottles finally converge. An automatic filling machine uses a high-speed rotary mechanism to inject the exact required volume of the electrolyte formula into just a continuous blur of moving bottles. And timing is everything here. Literally mere milliseconds after being filled, the bottles enter the cap sealing station. This is where caps are torqued on with exact mechanical pressure to create an airtight lock. Finally, a high-speed label application system wraps the bottle in its recognizable branding without tearing or misaligning the plastic film. It's honestly a mesmerizing, rapid-fire choreography of industrial automation.
And this brilliantly illustrates the true marvel here, the sheer scale of the operation. Millions, literally millions of bottles are rushing through these filling machines every single day. To actually manage this staggering volume, factory quality control relies on automated optical inspection. They've got high-speed cameras and sensors scanning hundreds of bottles per minute. They're instantly checking fill levels, making sure the caps are perfectly aligned, and instantly rejecting any single unit that falls even slightly outside of their strict manufacturing tolerances. There's just no room for error.
Which brings us to Section 5, Packaging for the World, Logistics and Shipping.
So the final leg of this physical journey moves the product right off the assembly line and into the broader supply chain. Robotic case packers step in and swiftly group the individual bottles, securing them into cartons. Those cartons are then stacked up by giant robotic palletizers and wrapped up tight for stability. From the warehouse floor, they enter vast global shipping networks. Just think about it. What started as raw water and tiny plastic preforms in a localized, highly controlled factory has now been transformed into a perfectly uniform consumer good, ready to be dispatched all across the world. So here's my question for you. Next time you hydrate, will you see the robotics and logistics hidden in the bottle? It's so easy to just twist off a cap and take a drink. But as we've explored today, there is a complex, beautifully orchestrated, and totally unseen industrial world behind every single drop. The engineering required to maintain that level of hygiene, speed, and precision is just truly remarkable. Thanks for joining me on this deep dive into the fascinating structures of modern manufacturing for this explainer. Keep learning and always keep looking for the hidden processes in the everyday objects around you.